Hi, hi. Hello, everyone. So in this video, we will go over chapter one for the networking course. It's called Living in a Network-Centric World. And it's nothing but a brief introduction about what we're going to study in this course, what are networks, and the basic terminologies that we will use throughout the course. So let's get started. So what is a network to begin with? Multiple connected devices or multiple computers that are connected together that can share information. So I would, in today's age, I would say multiple devices that are connected together to share or exchange information or messages. Um, that would be considered a network, but you'll understand it more briefly because there's a lot to it. In today's network, what can we do? If you are connected to a network, you can send messages, you can send audio, you can send videos, you can view videos, you can do a lot with being connected to a network. One of the biggest things that you're doing right now probably is watching this video through a network. You're able to watch it through a network. You can stream content from Netflix, from YouTube. You can do a lot of things when you're connected. That's all that I'm trying to say. All right. Now, how does it support the way that we live? In today's world, especially if you are not connected to a network, life, I don't know, would seem like the Stone Age where you have nothing to do because apparently we're doing everything over the networks or through networks these days. There are people, thanks to the pandemic, there are people who are working from home now. Usually previously you would see that people would work from offices. They had to go to office or to their workplace to work, but now it is possible for them to work from home as well because of the network, because of the internet connections, because of these devices that we have. One of the biggest changes over the pandemic is the fact that even education is starting to move online. Sorry. That means students can now learn from home, and we've seen that, a lot of schools, a lot of universities now use Microsoft Teams, Zoom, Google Classroom, Big Blue Button. All of these services are available over the network. So if you don't have access to the network, you wouldn't really be able to make use of these technologies, right? And network for now, just imagine that I'm talking about probably a connection that you have, let's say a Wi-Fi connection from Batelco, Zain, STC, or a mobile data connection that you have on your phone, again from the same service providers. So just assume that when I say network right now, it means you are able to connect to an internet service provider, which is Batelco, Zain, or STC. We can even send messages, instant messaging, which is WhatsApp, Telegram. Now there's Messenger as well. All of these services are also available over or through networks. Like if you don't have a network, if you don't have a data connection, what use will these services be of? There now you also we see a huge increase in people vlogging or blogging or vlogging. I don't know how that's pronounced, but that's again because they have network. They create a content and they put it up online for people to see, and they can put it up online because they are connected to a network. And webcasting again is usually before seminars and workshops used to be in person, but because of now COVID, also you can share um, uh, you know recordings or videos with wide audience at the same time. So that is how networks have changed our life. It's basically, I would say, consumed our lives because we don't know life without them, but they can be life changing if put to good use, like we are trying to do because of COVID these days. So now let's talk about the network itself. what should a network have in order to be able to, in order to be able to communicate? So for example, let's say I want to send an email to a student from this class, okay? What should I have on my end, and what should the user, or what should the student have on their end for the communication to be possible? The first one is the rules or protocols that govern handling the message. What does this mean? I'm trying to send an email, so I need to have a protocol um on my PC or whatever I'm trying to use to send the email that can align with the email sending rules, because every form of communication, every form of message, or anything that you're trying to send across the network has to abide by a protocol. If you're trying to browse on the internet, you're probably using HTTP, and that's why you would see in the hyperlinks, you see that HTTP, because that's the hypertext transfer protocol that you're using. If you're sending an email, there's another protocol that you should use. So all of these protocols, so email would be SMTP or POP protocol. Again, we'll look into that later. So in this case, I should abide by the protocol that is used for sending emails, okay? And that's nothing but rules and regulations that need to be followed. The second thing is I should have a message that I am trying to send from one device to another. So that email that I'm trying to send is considered a message in this case. Or maybe if I'm trying to send a file to somebody, let's say I'm trying to send a file to someone, that would be considered a message in this case. I'm trying to send something over the network to the other person, and that is basically considered the message. So that's the second one. The first one is rules, the second one is messages, and the third one is medium. What is medium? Medium is nothing but the connection that you have. If you have a wired connection, maybe you have an Ethernet cable that's connected to your laptop or to your computer, or maybe you don't have an Ethernet cable, but you have a Wi-Fi connection. So, you have a wireless connection. So that medium that connects you to the network is something that's required. So let's say you don't have the medium, you don't have the Ethernet cable, you don't have the Wi-Fi connection. Will you be able to send the email? I don't think so, right? So medium is important. And lastly, devices. So these devices that we see here, if I can highlight it here, if I don't have a device, I don't think I will be able to send an email. And if the other person doesn't have the device, they won't be able to see it either, right? So I should have a device for sending. They should have a device for receiving as well. So what are the four things that are required, or four components, elements? What are those? The first one is rules or protocols. Second one is messages, medium, and devices. These are the four elements or components. All right. Now, activity one, messages could take many forms in computer networks. First, find at least 3 types of messages and write about them. I think I've already given you the answer for this. So, okay, what you can do is pause the video for maybe a minute, think about it, and write them down on a piece of paper, probably. And after that, I will give you the answers on the video. So you can pause now and write the answers. Okay, so the answer for this one would be, let's say, the first one I already said was sending email. That's considered the first message, maybe. Okay, apologies for the writing, but let's just see it like that. The second one could be file transfer, like I mentioned as well before. All right, and the third one would be browsing. So you're browsing a web page. You're fetching the information from a server about a web page. for a web page, and then it's being displayed for you. The fourth one, I'll give you another one, bonus, instant messaging, WhatsApp, Messenger, all of that. All right, so it can take all of these forms. Now, let's move on. Now, let's get familiar with the devices. So remember how I spoke about devices here, that you need to have devices to be able to communicate or send messages. What are these devices? What can these devices be? All right, you can have a desktop computer for sending emails, browsing, for anything, obviously. You can have a laptop. You can have a server that's basically hosting a website. So you connect to the server, and that server sends you all the files for that website, and you're able to see that website. So that's another device. You can have IP phone. Now, IP phone, to this day, I don't know how they work, but they work somehow, and they're also considered a device on a network. All right. Now, these are the devices you can have. You can also have network devices. You can have a LAN switch. We'll talk about this later on. We'll learn what it means. You might have come across firewall for security protection purposes. You must have known, you must know about router or router. You can call it the way you want. You do you. Don't make fun of me if I don't choose the way you say it. So this is a router. This is considered a wireless router, and you must have seen this in your house as well. It usually has these two antenna-like things. And then there's a cloud. A cloud, I can, for now, just think, okay, a cloud is basically networks connected together. So networks connected with networks, connected with networks, interconnected networks. Okay, then we have media. Remember the medium in the four components if we go back. Wow, where is it? Yeah, we had medium, right? One of them was medium, which is nothing but how you're connected to the network, whether it's wired, whether it's wireless, all of those things. So there is something called LAN media. What is LAN? Again, we will look at it later. Don't worry about it. There's something called wireless media. We all know what is wireless, I think. How probably your phones are connected to maybe a wireless network. And then there is a WAN media. Again, WAN media, LAN media, there's a difference between that. We will look into that later on. Okay, packet tracer introduction file. For this particular activity, it's actually the first activity that you will do in packet tracer, and I wanted it to be a guided activity so you know how to use the tool. So there's another video that is available for this. You can watch that video and follow that video and try to do the activity at the same time so you know how to basically use packet tracer. And yeah, so for now, we will just skip this slide. Okay. Now, remember the four components. One of them was protocol or roles that should be followed. Here, we're just discussing some of the protocols that are available for the various services that we can use. So like I mentioned before, if you're using web, or let's say, oops, sorry, if you're using or if you're browsing, you're probably using HTTP or HTTPS, which is, if you notice, it's usually written in the address that you are trying to, what's it called? I forgot the name. Trying to browse. Yeah. So the URL that you're trying to browse, it will usually have HTTP in it, which refers that, okay, you're trying to browse, you're trying to use the World Wide Web Service, and HTTP is kind of like an indication for that. Like I mentioned before as well, for email, you have SMTP, which is Simple Mail Transfer Protocol, and there's another one which is called POP, and I am sorry for the drawings. let's just try to work with them. But SMTP is Simple Mail Transfer Protocol. POP is Post Office Protocol. You might want to remember the full forms, but you don't need to know them in detail yet. We will go over them later on. If you're using instant messaging, you would have something called XMPP. You could be using something called XMPP, which is Extensible Messaging and Presence Protocol. And then there's another one which is called OSCAR, which is Open System for Communication in Real Time. Again, you might want to remember the full forms, but don't worry about knowing them in detail. We'll go over them. iPhone, wait, it's not iPhone, IP telephony. I kind of put them together. This particular service is, remember the iPhone, oh my God, not the iPhone, the IP phone, the IP phone that I showed you here, this one. It's going to be using SIP, which is Session Initiation Protocol, if that's how you say it. So those are the services that are widely used, I would say. But then there are also other protocols that are used for DNS, which is Domain Name Server, DHCP, which is Dynamic, I don't know what's H. Wait, I forgot the full form. Let me just quickly Google it. What is DHCP? It's okay. It's okay if you forget things. You can always look them up. Dynamic Host Configuration Protocol. I know what it does. Don't think I don't know, but I forgot the full form. So Dynamic Host Configuration Protocol is the full form for that. Let me just write it here. I think that would be better, right? If I just write it here. So DNS is Domain Name Server. Don't worry at all. I will take you through all of this later on. This is Dynamic Host Configuration. I'll just write config because I don't have place, and then protocol. Okay, and then FTP is file, this one I know, file transfer protocol. Okay. There are other protocols as well, which is TCP, IP protocol, Ethernet routing protocol. We'll look into all of that later. Don't worry, as I said before. Okay, now let's put all that we learned so far to use. Okay, so here is a small example of how you can send an instant message. Okay, and so this person here is probably sending their instant messages in MSN. Looks like it. Maybe it's something else. Maybe it's Yahoo. Who knows? But the early form of WhatsApp, if you don't know. Okay, so they're sending their message, and we can see that here they're on a PC, and the person that they're trying to contact is actually on a mobile phone. I'm just going to assume it's a mobile phone. Maybe it's an old device that I don't remember what it's called, but I'm just going to assume that it's a mobile phone that has a pen. Okay, just think of it like that. So this person here wrote this particular message, okay, and they want to send it across to this person, okay. So I mean to this person here who was using a mobile. So what is going to happen? Now, if you've taken computer systems course, you know that devices don't understand human language. They only understand bits and sorry. They only understand zeros and ones, which are bits, right? So what happens is the first step is whatever message you're trying to send is going to be converted to bits. Okay, that's the first thing, because computers, devices don't understand human language. The second thing is the NIC will generate signals. NIC is nothing but a card on your device that allows you to connect to a network. Usually, it has an Ethernet port. Sometimes it doesn't, but it's a card that allows you to connect to to a network. So it will generate signals, all right? And those signals are just like electrical signals. So those signals will be passed through the LAN devices. Okay, what is a LAN device? Don't worry, we'll look at it. But there are many devices that can be on a network. So all those devices that are there, that are connected, the signals will be passed through all, or the signals will be transmitted through all those devices, and then they will reach an exit router. Exit router is nothing but a router that is connected to the ISP provider. Let's say you have a router at your home that's connected to Batelco or Zane or STC. That's your exit router. Everything comes to that router, and from there it goes to the network, which is the network, which is the data network here, this thing. It's nothing but interconnected networks. So all the networks are basically interconnected by the ISP provider. Don't go into, I don't want you to get confused by going into depth for this, but this is how it works. It's just interconnected networks together that determine which is the best way to reach the destination, and once that way is found, the message will be, or the bits will be transmitted to that particular destination. So bits, like I said, are transmitted to devices that interconnect the networks. Finally, when it reaches the destination can also have multiple LAN devices, right? So it will pass through all those devices and then reach the destination. So maybe there's a router here, there's a wireless router here, and the person is connected to a wireless router. Maybe you have an extender, maybe you have another router, who knows how you've designed your network. So however the network is designed, the bits that were converted by the sender will be transmitted to the receiver in that particular way. Okay, and finally, the device that the user has, not the user, the device that the person on the destination has will convert the bits that we had originally to human readable form, and then they will be able to see this message in the same exact way that the sender wrote. Okay, so that's how this is an example. Okay, it's not the concrete way of how network works. It again highly depends on how the network is designed. Like I said, maybe there is no router here and there's just a wireless router here. Maybe there is a switch here instead of not here, sorry, I meant a switch here instead of the wireless router. However, it depends on the design. All right, so that's an example of how it would work. At each of these steps, there are protocols that define the communication, which is exactly the rules that we talked about, one of the components, right? So this is the first step, this is the second, the third, the fourth. So between each of these steps, there's a certain protocol that is being followed. Don't worry about it right now. We will learn about it later on. But just so you know, at every step, there is a protocol that is being followed. Okay. Now, okay. Here, what they're trying to explain is, initially in the early days, every way. So let's say if you want to communicate using a computer, you would use a computer network. There was a different network for that. But the way you communicate on a computer, like email, browsing, file transfer, all of that, is not the same as how you communicate on a telephone. Telephone is also a network, right? On telephone, you are able to hear people, and the other people are able to hear you in real time. So that was a different network. That used to be called telephone network. And messages were sent in a different way. There were different rules for that. There are different rules for a computer network. And then there's another form of network, which is broadcast network, which is used for broadcasting for like TV channels or and programs and radio and all of that. So you need a different network for that. Uh, as in, you need to have a dish, a satellite dish at your home to be able to receive uh, or to be able to view a specific channel on your TV, things like that. Again, there's a different rule, there's a different standard, there's a different agreement in that that is being followed in that. But because of the increase in demand and how networking has changed over the years, what has happened is all of these particular networks, so the computer network, the telephone network, the broadcast network, all of them have now become one network, which is called the Converged network. And it again has rules, agreements, and standards, but it has become one. I can give you, it's like consolidating it into one instead of having separate networks. I'll give you one example for this. You have a plan with Betelco. Let's say I'm going to use Betelco, but it can be for anything, for STC, for Zain. Let's say you have a mobile plan with Betelco. They will give you uh, minutes for talking on the phone, right? For call minutes. I don't know what's the name, the proper name, but there are minutes that you get for talking on the phone. Then you have data that they give you in that plan. So basically, they're doing two things. They're giving you internet connection, but then they're also giving you telephone connection, right? So that's one example. Another example could be, or a better example could be the live TV. So before you needed to have a dish, a satellite dish at your home to be able to receive TV channels or to view TV channels. But now you can view TV channels live on your phone. That's possible because of the converged networks. Now you don't need to have a dish to be able to see the live channel on your phone. You don't need that. You can just watch the channel on your phone live without the need of a dish TV, and that's because thanks to the converged network, because it's all come into one, right? And again, converged networks have changed the way that we live, honestly. You can see that, a lot of people are online gaming. They connect to thousands of people around the world, and they are able to play games with them. You can see video conferences online. You can attend school online now, which is a good thing. You can work from home because of this. You can send messages. You can send video, text, no matter where the person is. Even if the person is on the other side of the world, you'll still be able to communicate with them thanks to the converged networks. So that is a little bit of about the network. What is it? What's a network? How do they function? All of that. But what are we here to do? We are trying to become. Let me write here. Network architects. What does that mean? If you think about it from the sense or from the perspective of building a house, before you build a house, you need to be able to design the house, right? So that it follows the proper structure, and all the necessities about it are taken into consideration. So who does that design? An architect, right? An architect basically designs the house, and then the house is built by whoever is building it, right? Our job here is to design that specific network. So that means we become network architects, right? So, but when we think about designing a network, basically we need to, our networks should have four things or four characteristics or four qualities in them that every network should have. Okay, and we'll look into them in detail. But it's basically how to connect people with the services that they want and apply the and because of those services be able to set the protocols right for them. Okay, that's the basic gist. So the four, like I said, the four characteristics here that are required by any network architecture or any network design are the first one is fault tolerance. Okay, the second one is scalability. The third one is quality of service or QoS, and then security. So fault tolerance, scalability, quality of service, security. By the name of it, you will know what it means, but then we'll look into it now in detail. So the first one is fault tolerance. A simple example that I'll give you for this is, let's say you go to a big corporate building, okay, the ones that are usually in CEF. You will see that all of them usually have multiple elevators. Okay, the tall buildings with, let's say, 20 floors or more, they usually have more than one elevator, from going from floor to floor. Why do they have multiple elevators? The first reason could be because a lot of people are coming in and coming out, and you know that's their requirement. But the second reason could also be that uh, what if one elevator breaks down? If one elevator breaks down, it's okay. The people can use the second one. Imagine going to the 40th floor if they only had one elevator and it was broken. What a terrible situation. So the same concept is being applied here. If you have a big building that's using a network and you only have one router and that router breaks down, the one that's connected to the provider, if that breaks down, everyone will lose connection, right? And there will be chaos and mess and overwhelm. So what do people usually do? They have a redundant router. There are other ways of doing this, but it's just I'm just giving you a small example. So they have the same exact router. You can say it's like a copy. It's like the same exact router, but it's a redundant router. So what happens is, if this breaks down, God forbid, if this breaks down, this is still working, and the connection is still working until, the people come and fix this, and then it goes back on track. But that's what it means. So you should have redundant connections to have fault tolerance in your system, sorry, in your network, so that if something happens, if something breaks down, you have your design of the network is able to tolerate that fault. Okay, that's fault tolerance. Scalability. Now, scalability is just the ease with which you can add more people or more users to your network without degrading the performance of other users. So let's say a friend of yours comes to your home and comes to your place and they ask you for the Wi-Fi password. All right. All they need to do is find the name of your router and then add the password, and they'll be able to connect. Imagine if you wanted to allow them to connect, and for that you had to go and change settings in your router just so that they can connect. It would be a nightmare, right? So this is the simplest example of scalability, like with the ease with which you are able to connect new users onto the system without degrading the other users. So it's not like if your friend uh, you know adds is added to the network, is using the Wi-Fi, it it means that other users cannot use it. It doesn't work like that. They can use, but the performance never degrades. Quality of service. Now, this is a bit tricky to understand, but you can imagine it in the perspective of managing traffic on your network. Just as the way a traffic police directs traffic, um, here the only difference is it's based on priority. So let's say the network that you're designing for a company or an organization, they mostly use streaming in their work. They don't do a lot of browsing or email, but they have a lot of streaming. So because we have a converged network, remember, we have a converged network which allows everything, which allows streaming, broadcasting, telephone networks, all of these are all in the same network. We need to be able to manage that traffic. So we can say that if streaming is required by this company, it should have the highest priority. Everything else should have a low priority. So in that way, when streaming traffic comes in, it's given the priority to exit first. Just imagine it that way. All right. So any of the media, sorry, any of the messages or any of the services that are being used by the users, you set a priority so that the most important services get the highest performance. So in this case, streaming will get higher performance because it has higher priority. But web pages, maybe they don't use, the company doesn't use it a lot. So you would set a low priority for that, and it might not have the best performance for that, right? So that's what quality of service really means. So you kind of like manage the traffic based on priority, and the priority is based on what the users want best performance for which service. All right. This is exactly what I explained. Converged networks allow you to do everything. They allow you to do real-time traffic, which is voice over IP. You're able to talk to a person. They can hear you the same time. They can talk to you. You hear them at the same time. You can browse. You can do transactional traffic, order, like this is just data entry stuff. And then you have video on demand, like you're streaming content, and bulk traffic like email and backups and all of that. So all of these are being done on one network, which is converged network. So what you do is all of them are not the same for each organization. Maybe like, let's say, like I said, um, one organization gives more priority to voice over IP. So you will set a higher priority for this one. Everything else you can set it to lower priority, and so the performance will be better for that particular service. Security. This is the easiest one. Let's go back to the same example where your friend comes to your place and they ask you for the Wi-Fi password, uh, and you give them the Wi-Fi password, and then they're able to connect. If someone doesn't have that Wi-Fi password, they're not able to connect to your network. This is how we make the connection or the network secure. That way, your neighbors are not using your Wi-Fi, unless they have the password. And even then, you can go back and change the password. So passwords ensure that unauthorized access is eliminated from the network, and only the people who have access or who have passwords can be able to use the network. Now, there's a trend that we see in networking. We see that there is an increase in the people who have, first of all, mobile users. We see a huge increase. We see a huge increase in people who are using devices like computers, laptops and stuff like that, but also mobile, right? And that's why services are developed for those mobile users. So I'll give you an example for this. Because there was an increase in the number of mobile users, Netflix became a big thing. People don't watch TV now, I think. People watch Netflix. Other platforms are available as well, but a lot of people use Netflix, right? Why? Because there's an increase in the mobile users. And because of that, a lot of people are starting to rely on such platforms. Another example would be because there were a lot of online users or mobile users learning through Microsoft Teams, Zoom, Google Classroom. Big Blue Button was they came into play, as in they were created so people can use and learn from home, right? And then that reliance was increased, as in people started relying on those services. And then because there was a lot of reliance, these services were used. So if you can see, this is the trend here. There's an increase in mobile users, which means that there's an increase in the demand for services. So services like, let's say Microsoft Teams were created, in they increased the reliance as well. So people started relying on them because they were able to use them, and because they were able to use them, and because they started using them more, the cycle keeps repeating. I don't know if this made sense, but it's just that you have more users, more services would be created, and because more services are created, people start using them and they build a reliance on them. And because there's a reliance, people start using it, more and more services start emerging. So because of this trend, this networking trend, um, there's an increase in the job or the requirement for people who can understand, design, and build networks. And that is because of the increase in the trend. That is because of the networking trend, increase in number of users, number of services, reliance, and all of that. As the network increase, there is a demand in the software, in this networking skills. Sorry, I said software, but it's networking skills. Okay, so one thing to keep in mind in anything that you're developing for a user, whether that's a network, whether that's designing a network, building a software, whatever that is, or building a service, you don't do it for anyone but the user. You do everything for the user. You're going to design a network. The most communication you should have is with the user. What are their needs? What are their expectations? What are their requirements? How are they going to use it? All of this is required. All right. If you build a network that the user is not going to use, that the user is as in it's not what the user wants to use or what they expected or what they needed, they won't use it, right? So you have to build your products or your services or whatever it is that you're building according to the user. Have conversations with the user, have interviews with the user, talk to them. What do they need? The user might not know everything about what they need. They will just tell you, oh, we should be able to send emails, but they don't know if they need SMTP or if they need POP. Which protocol should they choose? That is for you to decide, but the requirements come from the user. All right. And because of this, we need skills. All of us, no matter where you want to be, no matter which profession you want to choose, you need to have skills. You need to have the right attitude. You need to have the right enthusiasm. You need to have the right communication skills. Remember how I said about needs, expectations, requirements, and uses that the user needs to have? You should have communication skills to be able to ask the user about all of those things. You should have the professionalism and ethics that you tell them the right thing and you don't tell them to do things or to ask for services that they don't need. You have to be ethical in that perspective as well. So all of these, my best advice is that this time that you have, these 4 years in this degree that you have, are the best time to practice these skills, because once you're out in the workplace, nobody cares about you. Trust me, nobody really cares. If you have skills, good to go. If you don't have skills, you might not get the job, right? So how can you practice these skills? My suggestion is every semester, take one skill. For example, this semester, I'm going to practice my communication skills. What does that mean? Maybe every time I write an email, I'm going to Google about what's the best way to, or what's the most professional way to write this email. Or every time I have a question, I will phrase it in a way that is more professional. I will try to look up new words that I can use, for in my communication. Things like that. Every semester, work on one of these skills, because I can tell you, These are important. You will not get anywhere if you lack these skills, even if you're the best at other technical skills. You need to have these soft skills to be able to, grab good opportunities. So make sure you work on those. The attitude, again, make sure the attitude here really means, let's say someone on your team makes a mistake. You're not the one who's yelling. You shouldn't be the one who's yelling. You shouldn't be the one who's creating mess, overwhelm, and chaos. You should be the first one to step out and say, okay, what's the first thing we can do to fix this? um, you should have an enthusiasm to learn new things. Maybe there's a project that nobody knows about. You should be willing to learn about it and to take that project on hand. Communication, I've already discussed. Professionalism, I've already discussed. Ethics, again, this is based on moral values. If you don't lie to people, you don't cheat people, you are ethical in what you do, and I promise you ethics will build your reputation more than anything else. So try to work on all of these. These 4 years are your practice years. Once you're out, you're out. Once you're out of university, you're on your own. Nobody's there to guide you. So please make use of this time to practice all of these skills and everything. Okay, I think that's it. If you have any questions, you can email me, message me on Teams, or post it on the forum on Moodle, which is probably the questions forum. And yeah, thank you for watching and see you next time.